Good morning, Knights. Welcome back to Chemistry Online. So today we're going to be talking about periodic trends. We're just going to continue where we left off last time. So last time y'all were here, we talked about atomic radii, or atomic radius, which basically tells us the size of an atom. And I just wanted to review it real quick before we moved on to the next trend. So basically, the way to get the atomic radius is you're going to measure from nucleus to nucleus. So here we have two atoms. So here's atom number 1, atom number 2. And this is our first nucleus. This is our second nucleus. We're going to measure the distance between the two. We cut that distance in half, and that's how we get the radius of an atom. This is a question you'll be tested on, which is why I want to reiterate it. So back to atomic radius, or atomic size is another way to put it. This is just an image to show you guys what they look like relative to each other. So this is group 1, so I put group 1 right here. So hydrogen, of course, is the smallest, and then you jump up to lithium, and lithium adds an energy shell. That energy shell makes everything in that row larger than the row before it, the period before it, sorry. So after lithium, we have sodium. Sodium gets larger because it's adding an energy shell. Potassium comes next, adds an energy shell, becomes larger. Rubidium comes next, adds an energy shell, becomes larger. So as you move down on the periodic table, you're adding an extra electron cloud, which ultimately makes the element larger. And then we have atomic radius across a period. And you could see, so this is going to be period 2. No, this is period 3. And so first we have sodium. Sodium is large. Magnesium adds an electron, adds a proton, which makes the element compact. It's got a greater electromagnetic charge. So it's got a greater electromagnetic charge, which causes the element to get smaller, which means it's adding protons, it's adding electrons, and those just, they compress the size of the element. So moving across a period on the periodic table is going to shrink your atom. So from sodium to magnesium, it gets smaller. To aluminum, it gets smaller. Silicone gets smaller. And that trend just carries on all the way to the very end. Let me move my image real quick. So we're talking about argon right here at the end. That's the noble gas. It just continues getting smaller as you move forward. All right, so today we're going to be talking about ionization energy. So ionization energy is just like what it sounds. It's the energy required to ionize an element. And what is ionizing an element? That's when you take an electron away. So what is ionization energy? First thing I want y'all to do is I want you to write the definition for ionization energy. That's this right here. It's the energy needed to pull an electron from an atom or to steal an electron from an atom. We'll talk more about stealing electrons in the next trend because we're going to talk about 2 trends today. But it's the energy needed to pull an electron from an element. So here, if we look at this element, it's got 2 plus 8 plus 2, which means this is going to be, let's look at a periodic table. That's going to be magnesium. So magnesium has 2 electrons in its outermost shell. And the energy required to pull one of those electrons away, that's the ionization energy. So the greater the ionization energy, the more difficult it is to remove an electron. That's just part of the definition. If you need to write that down, I would write it down. The more electrons on that energy level, the more difficult they are to take away. Which means if you have 1 electron in your outermost shell, it's easier to take away than if you had 2. And we'll talk more about that in a minute. All right, so this shows you how the trend goes. Ionization energy increases as you move across the periodic table, as you move to the right. And ionization energy decreases as you go down go down the period on a periodic table. So, and here's why. So let's assume this is group 1 on the periodic table. So here we have our hydrogen, our lithium, our sodium, our potassium, and then our rubidium. So what do we know about everything in group 1? We know everything in group 1 has one valence electron. So I'm just going to draw one valence electron on the outermost shell. So which one do you think is going to be easiest to take away? Think about stealing. If you wanted to steal something from somebody, not that stealing is right. You should never steal from anybody. But if you're an electron, then if you're an element, it's okay to steal electrons. That's just the way it is. So which one is going to be easiest to take away? Is it going to be the electron that's in direct sight? Because here we have our proton in the center. I'm going to draw our protons. So our protons are at the center of all of these. Which one is going to be easier to take away? Is it going to be the one that's really close to the proton or the one that's far from the proton? So the answer to that is the one that's farthest away from the protons. So the farther away it is from the center, the easier it is to take away. So ionization energy decreases as you move down periods on the periodic table, which means the larger the element, the easier it is to steal an electron away from it. So even though everything in this group is easy to take an electron away from it, rubidium is going to be the easiest. Francium is right here at the bottom. Francium is actually the easiest because it's got one valence electron. That valence electron is really far away, and it's not going to get too mad if you take it away. So the smaller the element, the greater its ionization energy is going to be. And then as we move this way on the periodic table, elements also get smaller as we move to the right, and those are also going to be more difficult. So the more electrons an element has, let me see if I have that. I don't have it on the next slide. But the more electrons an element has on its... I can't really draw it because I didn't include it, but let me try. So let's do it like this. That's an incorrect trend. That's my bad because elements are going to get smaller. Okay, so as we move to the right on the periodic table, we know that elements get smaller. And what we also know about, let's say, group 2 on the periodic table. So group 1 is up here. It's not included. So this is group 2. So what we know is as we move across the periodic table, we're increasing number of electrons. So this one has 6, and then this one has 5. Let's erase one of these. So this one has 5, and then this one's going to have 4. So the more electrons it has on its outermost shell, the more difficult they are to take away. So an element with only one valence electron, that's really easy to take away. Or an element with 2 valence electrons, those are going to be much easier to take away than if that element had 7. Why? Because this 7, it wants to be an 8. So it wants to gain that 1 electron so it could be like that next noble gas. So if it's got a lot of valence electrons, if it's got 7 or 6 valence electrons, you need to know that's going to have a really high ionization energy because it doesn't want to lose an electron. It wants to gain an electron. Whereas these guys right here, they want to lose their electrons. They want you to come take one of those electrons away. All right, so it says circle the atom with the highest ionization energy. So first thing I want to do is I want to tell you which element has the greatest ionization energy. If you know that, you're going to be able to solve all these problems without any question. So highest ionization energy, I'm going to put highest ionization energy. That's going to be fluorine. Least ionization energy, that's going to be francium. So this one is the most difficult to take an electron away. And the truth is, noble gases are more difficult to take away. But when we're talking about periodic trends, we don't mention the noble gases. They don't really matter here. They're excluded from the periodic trends. So fluorine is going to be the one with the highest ionization energy. Of course, that's excluding noble gases. The least ionization energy, which means the one that's most willing to give an electron away, that's going to be francium. So this is the greatest, and then this is the least. So the closer it is to the greatest, the greater its ionization energy. The closer it is to the least, the lower its ionization energy. So let's take a look at A. A says it's got fluorine, oxygen, and boron. So fluorine, oxygen, and boron. And it says which one has the highest ionization energy. We know that the highest is going to be fluorine. Next one is going to be arsenic, nitrogen, and phosphorus. So arsenic is right here, phosphorus, and then nitrogen. Which one is going to have the highest ionization energy? So we're gonna go with closeness. The one that's closest to the fluorine is actually going to be nitrogen. So this one is going to be our strongest here. All right, next one is going to be fluorine, carbon, and lithium. That one, of course, is going to be fluorine. Whenever the question includes a fluorine, it's a fluorine. And fluorine is the most a lot of things. It's the smallest element. It's got the highest ionization energy. And when we talk about electronegativity, it's also the most electronegative. All right, so explain why it takes more energy to remove an electron from fluorine than oxygen. So the reason is, here's oxygen. Oxygen has 6 valence electrons. Fluorine has 7. Which means fluorine, it just needs 1 more to be happy. Oxygen needs 2 more to be happy. Which means fluorine is holding on to the 7 it has really tight, and it's not willing to let them go. Oxygen is doing the same thing, except it's just more willing to let them go than fluorine is. Fluorine will never let an electron go. It holds on to them really, really tight. All right, so ionization energy trends. This you don't need to write down. More than 1 electron can be removed from an atom, so just keep that in mind. So even though you could take away 1 electron, you could also take away the next electron. And the second one's always going to be higher. So after you take away the first one, the next one is going to be even more difficult to take away. That's basically all we're trying to say on this page. And that you need to know that you can remove more than 1. All right, next we're going to talk about electronegativity. So first, I want you guys to write the definition for electronegativity. That's going to be the ability of an atom to take an electron away from another atom. So last we talked about ionization energy, which is the energy required to remove an electron. Now we're talking about electronegativity, which is an element's ability to steal electrons from something else. So electronegativity, it decreases down a group because there are more electron shields to the nucleus. And electronegativity increases across a period because of an increase in the nuclear energy. You actually don't need to write either of these. They're not that important. We'll talk about the trend in a second, though. What you need to know is the elements that are most able... So the most electronegative element, we should probably start there. Most electronegative, that's going to be fluorine. We already talked about it earlier. And then the least electronegative is going to be francium. So why is fluorine the most electronegative? It's the most electronegative because it's already got, so I'm going to draw a little fluorine here. It's already got 7 valence electrons. All it needs is 1 more. And because it's so close to having everything that it wants, it's just going to come up and steal it from you. And fluorine is so tiny, it's so small that its electromagnetic pull is very, very powerful. That means it's positive, its nucleus is very close to those 7 electrons. Just think of it as it has a gap right here, and that gap is really close to where the positive charge is, which is why it's so easy for it to steal electrons. All right, the least electronegative element, that's going to be francium. So francium has 1 valence electron. It's not going to steal anything from anybody. Its positive charge is really far away from that 1 valence electron that it has. It's not going to be able to walk up to another element, steal an electron from it, just because of its size. So the larger an element is, the less electronegative it is. So everything in group 17 has 7 valence electrons. So next we have chlorine, we have bromine. So bromine also has 7 valence electrons. except bromine is so much larger than fluorine. So here's our fluorine, here's our bromine. Bromine is so much larger that it's less electronegative. Even though it's already got 7, it just wants one more. It's less electronegative than fluorine. Fluorine is the most electronegative. All right, don't worry about this one. All right, so electronegativity trends, let's talk about them real quick. To answer all of these questions, all you need to know is fluorine is the most electronegative. The closer something is to fluorine, the more electronegative it is. Francium is the least. So here's our least, here's our most. So highest electronegativity, fluorine's included, so obviously that one's going to be fluorine. Let's just put them in order so that you get a little bit more practice. So highest electronegativity, fluorine, and then we have sulfur, and then we have SN. So these guys are already in order. So the second most electronegative is going to be the sulfur, and then the tin is going to be the third most electronegative. All right, next group we have lithium, nitrogen, and oxygen. And those are going to be the same. So the closer they are to fluorine, so oxygen is going to be 1, nitrogen is going to be 2, lithium is going to be 3. So 1, 2, 3. Most electronegative being oxygen. All right, so which is the smallest atom? Explain. So smallest atom here, let me pull up my periodic table. So you can't answer questions like these without a periodic table. I hope you have one. I know I gave you guys one if you came to school at some point, but if you never came to school, then you probably don't have one from me. You'll just need to go into Google and find one. All right, so lithium, sodium, and beryllium. Where's beryllium? I don't usually lose elements. Anybody see beryllium? Oh, there it is, my bad. It's right next to lithium. It's right at the top. All right, so sodium. Here's how they look on the periodic table. So you have hydrogen, lithium, beryllium, and then sodium. So here it's asking which is the smallest atom between these. And we know hydrogen is not included. So smallest element between these. So we know that lithium is smaller than sodium because sodium adds an extra electron shell. So we can already exclude sodium. So we're just answering between these two. Which one is smaller? We know that as they increase protons and electrons, they get smaller. So beryllium is going to be the smallest element here. All right, next one, which one has the highest electronegativity? For this, we just need to see which one is closest to sulfur. So we have arsenic, tin, and sulfur. Or we need to see which one's closest to fluorine. So let me grab my periodic table. So arsenic, tin, and sulfur. Here's arsenic, here's tin, and here's sulfur. So sulfur is the closest to fluorine. Therefore, fluorine is the correct answer to this. Or sorry, sulfur is the correct answer for this one. And the following pairs, which one has the larger atomic radius? Explain. So first one says magnesium and barium. So magnesium and barium. So magnesium and barium, they're in the same group on the periodic table. They're both in group 2, magnesium, barium. Barium is much larger because it's got greater electron shells. It just has more electron shells. Next one we have is copper or copper 2 positive, which means this one has 2 fewer. So when it has a positive charge, that means it lost 2 electrons. So because it lost 2 electrons, this one is going to be smaller. So copper is going to be larger. We talked about this one last class, I believe. All right, next we have sulfur and then sulfur 2 minus. So this one actually has 2 more electrons. So because it's got a greater, because it has a greater negative charge, that means it gained electrons. Because it gained electrons, that means it became larger. Sulfur 2 minus is going to be the correct answer here. Next one in the following pairs, which has the higher ionization energy. So higher ionization energy, it just needs to be closer to fluorine. So lithium or cesium, lithium is like they're both in the same column, but lithium is going to be considered closer to fluorine. And cesium is closer to francium, which means it's got lower ionization energy. Next, we have calcium and bromine. So calcium's all the way over on this side. Bromine's all the way over on that side. Higher ionization energy is going to be bromine. Bromine is really close to fluorine. Calcium is way far away. So that one's easier than you think. All right, so name the smallest element excluding noble gases. All right, so in order to answer all these trend questions, as long as you know which one is the greatest and which one is the least, it makes answering the questions very easy. So smallest element, of course, that's going to be fluorine. Largest element, that's going to be francium. Element with the most ionization energy, that means the one with the most difficult to take away electrons, that's going to be fluorine because it's very, very small and it's got 7, so it's not willing to give any away. Least ionization energy, that's going to be francium. Most electronegative element, that's going to be fluorine. Least electronegative element, that's going to be francium. So it's kind of coincidence, not really. But as long as you know what's what, these questions are going to be very simple to answer. A lot of people get these confused, though. All right, so atomic radius, what is it? It's an element's size, or an size of an atom. For ionization energy, it's the energy required to remove an atom. To remove an electron. Electronegativity, that's the ability to steal electrons from another element. All right, so trend across the period. So that's as we're moving to the right and left on the periodic table. So for atomic radius, they get smaller as you move to the right. Trend across a group, so they're talking about up and down. They get larger as you go down. All right, least atomic radius, which means smallest element, that's going to be fluorine. And then greatest atomic radius, that's going to be francium. For ionization energy, the trend across the period, ionization energy increases as you go to the right. And then when we're talking about groups, decreases and then electronegativity, it increases. Man, my handwriting is no good today. And then electronegativity, it decreases. And then for ionization energy, the least ionization, or sorry, greatest ionization. I'll put so here I'm gonna put least and then most, and then here for least we're gonna put. So the element with the least ionization energy, that's gonna be francium. So least ionization energy, that means there's very little energy required to remove that electron. Most energy required to remove an electron, that's going to be fluorine. And then for electronegativity, most electronegativity, that's going to be fluorine. And then least electronegativity, that's going to be francium.